Hi everyone, today we're going to be solving USACO 2019 January contest silver problem number 3 called Mountain View. And the problem reads, from her pasture on the farm, Bessie the cow has a wonderful view of a mountain range on the horizon. There are N mountains in the range, and if we think of Bessie's field of vision as the XY plane, then each mountain is a triangle whose base rests on the x-axis. The two sides of the mountain are both at 45 degrees to the base, so the peak of the mountain forms a right angle. Mountain I is therefore precisely described by the location x sub I, y sub I of its peak. No two mountains have exactly the same peak location. Bessie is trying to count all of the mountains, but since they all have roughly the same color, she cannot see a mountain if its peak lies on or within the triangular shape of any other mountain. Please determine the number of distinct peaks and therefore mountains that Bessie can see. So the input format is going to be, the first line of input contains n, the number of mountains, and the next n lines are just going to be the coordinates of the peaks of the mountains. And then we're going to print out the number of mountains that Bessie can see. So ones that haven't been blocked off by other mountains. And I've drawn out the XY coordinate that these mountains are on. So as you can see, we have the peaks of mountain 1, 2, and 3 labeled, and 1, 2, and 3 just refer to, so this is 1, 4, 6 would be 1, the first mountain, and then this would be the second, and this would be the third. So, oops, sorry about that. So, what we're going to do to solve this problem is use this equation right here. And this is the absolute value graph equation, but it's for inequalities. And the reason why we can use this is because these graphs, or each of these mountains, are their own absolute value function. And you can see that all of them have a slope of 1 on the left and a slope of -1 on the right. And they can be represented by this equation right here. This would represent the horizontal translation, while this would represent the vertical translation, or they would represent the coordinates of the peak. And the values going in here are going to be other values that we're just checking if they are covering the mountain or they're not. So what we're going to do in this problem is we're going to create two integer arrays, and one of them is going to be all of our x values, and this is right here, and one of them is going to be all of our y values right here. Don't worry about the I and j's here, we're going to talk about that in a second. But basically what we're doing is we're going to be going through each coordinate, and then we're going to check if that coordinate is ever covered by the other coordinates that are there using this equation right here. So our values are going to be, so the I represents what we're on right now. So if we plug that into the equation right now, we're going to get this. We're going to get y is greater than or equal to the absolute value quantity x minus 4, and then plus c at the, plus 6 at the very end. And basically what we're doing is we're going to plug in the other coordinates, so that in that case it would be these right here, these, and that's how you can see j right here. So you would plug in these first, and then you then plug in those after, and you would use these using, you would do this using a nested for loop. But you realize that when you plug those coordinate values into the equation, if the inequality becomes true, that means that that mountain is being covered. So then we're going to set a value that we usually would set equal to 1 equal to 0. And once it becomes 0, that means that it can't be seen, and when we add it to the answer, instead of adding 1, it's going to add 0. So the algorithm should work. And let's take a look at my code over here. So we have public class mountains. I imported java.io and util. And then right away you can see I declared all my variables I'm using. So print writer to print it out to mountains.out. I declared that right here. And then we have another one for integer variables. We're using these arrays x and y. And then we're also using that one integer n, which represents the number of mountains. I also have a separate variable for input, and that's fast reader right here. This is just a simplified version of buffered reader, string tokenizer combined, just to make it easier for myself. And let's move on to our main method. So this is where I declare my two input-output variables. And then I have init and solve method calls. And that's just to make my code look a little better. So we initialize right here. So first we're setting n equal to s.nextInt. The first integer right here, 3. And then we're initializing these two arrays so we can set them up. Make their length equal to the number of mountains, or mountain peak coordinates. Then this is just where we set the values equal to the arrays. So 4, 7, and 2 would go into the x array, and 6, 2, and 5 would go into the y array in that order. Then it's going to go to the solve method. So instantly you can see I'm referring to the c variable again. And then we also have the answer variable. And then here's our nested for loop algorithm. We're going to do int I equals 0, starts at 0, and less than or equal to n. And the same thing for j, because we're going through both arrays and we're trying to do every combination of coordinates so that we know exactly like which mountains are covered and which are not. So first we're going to set c equal to 1. So what we're doing here is we're saying that in this example, when c equals 1, that means currently this mountain I 4, 4, 6, so the coordinate at I, which is 4, 6 right now, if c is equal to 1, that means it's currently visible. And then we're going to check if it's not visible by going to this part. And first thing we're going to check, if I is equal to j, that means that we're checking the two same mountains, and we don't want to do that. So instantly we're going to continue it, which means we go on to the next iteration of this for loop. And then we use our algorithm for the next iteration. So in this example, we would get to coordinates 7, 2 for j, and I would still be 4 and 6. And in this case, if we plug it into the equation, we're going to end up getting false because it's this I coordinate is not being covered by this j coordinate. But you'll see that if we had a different example, like if we switched these and we said I is so if I was 7, 2 and j was 4, 6, now let's create a new equation with that. Let me erase this and this. So if I is 7, 2, then the new equation is going to look like that right here. And then if we run through the algorithm, we're first going to check if 4, 6 works. So 6 is less than or equal to. 4 minus 7 is going to be 3 or negative 3. And then if we solve the equation, you're going to get 6 is greater than or equal to 5. And this is going to be true. And if it's true, look what we do. We set C equal to 0 and we break. Because since we already know that one mountain is being covered, we don't need to check if the other mountains are covering it too. All we want to know is if one mountain covers it or not. So if it's covered, set C equal to 0 and you'll see that answer is going to get nothing added to it. But if this thing is false, which means that if it runs through all the coordinates and no mountain is covering it at all, then it's going to add 1 to answer, which means that, yeah, it's being seen. So in the graph example, you'll see that 7, 2 is this point right here, and 4, 6 is this point right here. So you can clearly see that 4, 6 is covering 7, 2. If I shade this even more, then you'll see that it's covering it fully. And that's why, in that case, it would have been true. So I hope that was helpful, and now I'm going to submit the code. Right here, and let's see if it works. Rating in progress. It's looking good so far. Yep, and all of them worked.